Hello friends and welcome to mathematics video lecture series. We are studying complex number and today I'll be telling you about cube roots of unity. So let's begin. Cube roots of unity. So unity here means 1. Okay. So suppose that the cube roots of unity are represented by the variable z. So obviously z cube will be equal to 1 because it is a cube root. So if you cube it up, you will get 1. For example, 8, the cube root of 8 is 2. So 2 cube will be equal to 8. Let us take it on the left side. So z cube minus 1 is equal to 0. This is a simple cubic expression. A cube minus b cube. And a cube minus b cube is nothing but a minus b, a square plus ab plus b square is equal to 0. So z minus 1 is equal to 0, or z square plus z plus 1 is equal to 0. So from here I get z is equal to 1, and this is a simple quadratic equation. The coefficients are a is equal to 1, b is equal to 1 and c is equal to 1. So the roots will be plus minus b plus minus root b square minus 4ac upon 2a. So z is equal to minus 1 plus minus 1 minus 4 upon 2a. So z is minus 1 plus minus 3 upon 2. And this minus root of minus 3 is nothing but root 3 into root of minus 1 using the property of surds. And root of minus 1 is nothing but iota. So z becomes minus 1 plus minus iota root 3 upon 2. So I have the roots. First root is 1, second root is minus 1 plus root 3 iota upon 2, and the third root is minus 1 minus root 3 iota upon 2. Okay. Now if you see, z2 and z3 are the complex roots because z1 is equal to 1 is a real root. Z2 and z3 are complex root because there is iota attached to them. If you see, there is iota here, so they are complex numbers. Okay, so let me assume we use a symbol omega for the complex roots, and you have the discretion. You can call omega any of the complex root. So let us say that z2 is omega. So z2 is minus 1 root 3i upon 2. Okay, so if I square omega, what will I get? Okay, this is the omega and I have to square it. So a square plus b square plus 2 into a into b. Okay, this will be 1 by 4. This will be 3 by 4 into minus 1. I square is minus 1, and this will be 2 cancels out, minus root 3i by 2. If you solve it, you will get minus half minus root 3i by 2. And behold, this was nothing but z3. So basically, I can say that the roots are z1, z2, z3. This is 1, z2 I have assumed omega, and z3 we found is omega square. So what are the three roots? So the cube roots of unity are 1, omega and omega square. Okay, let us discuss some properties of cube roots of unity. Okay, suppose I add the three roots 1 plus omega square. this will be nothing but 1 plus minus half root 3 iota upon 2 plus minus half minus root 3 iota upon 2. Clearly you can see that this is 0. So the first property is that the sum of the cube roots of unity is 0. And this is most extensively used in problem solving. Let us go into the second property. If I multiply the 3 roots, I will essentially get omega cube. Now what will be the value of omega cube? If you remember the main equation, z cube is equal to 1. And since omega is a root of this equation, so omega will satisfy this equation. So if I put omega in place of z, I will get omega cube is equal to 1. So 1 into omega square is nothing but 1. So the product of the roots, cubic roots of the unity is 1. Or we also use it directly as omega cube is equal to 1. Second property, omega cube is equal to 1. This is also very, very extensively used. Let us talk about the third property. As you might have guessed, omega into omega square is equal to 1. So omega can be written as 1 upon omega square. And omega square can be written as 1 upon omega. Okay. In the next lecture, I'll continue with the properties. Since time is running out, we'll meet in the next video lecture and we'll continue with the properties of cubic roots of unity. Okay, so stay tuned. Thank you.